I hope this is not upside down, but we'll see when I upload it. Let's review the formulas that we have discussed in Chapter 9. We will do one column for a significance test for proportions and one for a significance test for means. So we're going to kind of do them at the same time so we can talk about the difference between the two. So remember, proportion means you would see words like percent, or you'll have a fraction, 5 out of 15, where if you were to use means, you would see average, the word average, you might actually see the word means. So the symbol for your statistic, when you are dealing with a proportion, the symbol is p hat. For a significance test for means, the symbol for the sample mean is x bar. The symbol for your parameter, proportions, is p, mean is mu. All right, the procedure. We are doing a one sample z-test for proportions. And for means, we're doing a one sample t-test for means. All right, the random conditions. So remember, these are the 3 conditions that that have to be met in order for the test to be valid. So the random condition, you need to see words like simple random sample or randomly selected, or you can just see the word random. Now, this is true. This is the wording for both types of tests. So you could see simple random sample, you could see randomly selected, you could just see the word random, and then you know the random condition has been met. When you're checking the random condition, just be sure you say the random condition has been met because it was stated in the problem or something along those lines. All right, your 10% condition is the same for both of these. This is where our sample size is got to be less than 1/10 of the entire population. This 10% condition is the same for means as well. Remember, your 10% condition is the condition that checks for independence. We have to check the 10% condition if we are sampling without replacement. Okay, so that's why we check the 10% condition. And be sure when you are checking these conditions, you put a check mark or something so the reader knows that you have verified the condition, and then back up the reason you verified it in a sentence or showing that the sample size is less than 1/10 of the whole population. All right, the normal condition is different for these two tests. When you're dealing with proportions, to check the normal condition, this is your large counts condition. NP and N times 1 minus P have to be greater than or equal to 10. So make sure you are using the null hypothesis P, not the sample, using your proportion P. So both of those have to be greater than or equal to 10, and then the sampling distribution has a normal shape. But if you're working for means, if you're working with means, the first thing you do is when you're reading, if it tells you the population distribution is normal, then the sampling distribution's shape is going to be normal. If you have your sample size is greater than or equal to 30, then the central limit theorem applies and the sampling distribution shape will be approximately normal. If your sample size is less than 30, remember this is where you have to graph your data. And you would graph your data and you would look for the absence of strong skewness or outliers. So when you're checking your normal condition for means, many different scenarios can arise. All right, so the formula for the mean of the sampling distribution. So the mean of p hat for proportions is going to equal p, but the mean of x bar for means is going to be mu. The formula for the standard deviation of the sampling statistic. The standard deviation of your sampling statistic is the square root of p times 1 minus p over n. And the standard deviation for the sampling distribution of means is going to be sigma over the square root of n. Now, we're not going to know sigma, so you're going to use your standard deviation from your sample, square root of n, and in your formula sheet, that is abbreviated the standard error of x bar. All right, the general formula for your test statistic, it's the same for both of these methods. The general formula is going to be, is your test statistic is going to equal your statistic minus your null value divided by the standard deviation. So this is written for you on your formula sheet. What I'm getting ready to write next is not on your formula sheet, but all of these formulas are on your formula sheet somewhere. You'll just have to put it all together to get your specific formula for your test statistic. All right, so your test statistic for proportions is Z, and that's equal to the statistic, p hat, minus your null or your claim, which is p, divided by the standard deviation, which is right here. P times 1 minus p over n. Now the specific formula for the test statistic for a significance test for means. Your test statistic is T. Your statistic for means, x bar, minus your null value, mu, divided by the standard deviation. And there are your two specific formulas. Now, when you are doing your 4-step process, it is not necessary for you to write this general formula because that is given to you on your test in your formula sheet, but I would like to see these written out. That way the reader knows exactly what you're doing. All right, so then when we draw our picture, so your picture for proportions, again, if the normal condition has been met, it's normal with a mean of p and a standard deviation of p times 1 minus p over n. And then your test statistic in this case is t. And remember, we have to find our degrees of freedom. And degrees of freedom is your sample size minus 1. And then how to find the p-value. So since proportions is a Z test, we can use table A or normal CDF. And since the significance test for means is a T test, we can use table B or TCDF. And just remember your degrees of freedom are n minus 1. So this is one piece of paper that has everything on it that you need. It also has the 4-step process down here for you to follow anytime you're writing a significance test. You want to make sure you follow these 4 steps. But remember, you don't have to put the general formula. Definitely picture the specific formula, the work, meaning fill in the formula with the numbers, then what the value of your test statistic is, and your p-value. And always make your conclusion in the context of the problem. Use the problem. Use the question that's asked, and just restate the question that's asked with the decision that you're going to make based on your p-value. And that's the easiest way to not worry about your grammar.